All right, so measuring this is going to be pretty interesting because, like I said, we have series and parallel switches on both sides of the transformer. And so I've decided that we're going to test this, all of the various things about this amplifier, the frequency response, the distortion, the output impedance, the gain, the noise performance, everything in every one of those modes. And so the way we're going to do this is we've got switches here, and we're going to do them in down, down, up, down, and down, up, right? And so that's going to give us, each one of those is going to give us different, well, one of them, the ups and the downs should give us identical gain, right? But they're going to give us different distortion. They're going to give us different output impedance, because one of those is series, one of those is parallel, right? And so the other one is going to be series parallel, and the other one's going to be parallel series, right? And so those are going to give us different gains and different output impedances and probably different distortions and maybe different noise measurements too. And so we get to go through all of these and find out, you know, what's the best. You know, I assume it's going to be 1-to-1 series is going to be the best of all of them measurement-wise. But, you know, maybe I'll be wrong. It'd be interesting to see. So let's get started. The first thing we're going to look at is I just want to check and make sure the bias is still on. And it is. So I'm just checking the bias here. We're at 22. I wrote 22 on the sheet. So it looks like that's good to go. So I'm going to turn that off for now. I don't want that beeping at us. It's the most beepy scope ever. It just beeps continually, complaining about everything. All right, you can see that we've got 1 volt there. We're putting 3 peak to peak in, and we're getting 2.88 peak to peak out. And so you can see that we're in, what are we in here? We're in down, down. And so down, down is a unity gain mode for the output transformer, but as you probably know, cathode followers are always slightly less than unity gain, right? And so that's a thing, right? So we got to figure out what the gain is for every single mode here. And so I'm going to just go ahead and write all this down. All right, so let's get started on our gain. We're going to start with, this is the order we're going to do them. We're going to do up, down, down, up. And so we're going to start with up, and we can see that our gain is going to be 2.88 divided by 3. That's peak to peak measurement. 2.88 divided by 3. Okay, so up is a gain of 0.96. Let's do down, down. All right. It's between 2.88 and 2.92. Let's just say it's 2.9. 2.9 divided by 3. And that gives us a gain of about 0.97. So let's do up, down. Okay, up, down. So this is the low gain mode. We've got a peak to peak now of 1.92. So it's going to be a 1.92 between 1. We'll just wait 1.92 divided by 3 is what we want. Okay, now the last one that we get with up down, we got 0.64, so that's low gain mode. Now we're going to do down up, so that should be high gain. And so it is. So this is our only mode in which we achieve better than unity gain, and it's going to be 4.35 divided by 3. And that gives us a gain of about 1.45 in that mode. Awesome. All right, so now let's have a look at what the square wave looks like. Let's go back to our initial mode here. So we're going to be up, and we'll flip over to square wave here. And you can see that we have a little bit of ringing here. The high frequencies right there. Interesting. So that's an up. So I'm going to go ahead and write down that we've got a little bit of ringing. Next, let's have a look at down, down. And you can see that even though both of those are the same gain, they're both sort of the medium gain modes, that this one, down, down, is much better. So it's a much better square wave. All right, now let's look at our low gain mode. That's going to be up, down. Up, down. And you can see now we actually have, once again, a little bit of high frequency ring. I'll write that down. All right, and lastly, let's have a look at down, up. This is our high gain mode. Down, up. And that one has a little bit of ring, but it's actually more well behaved than the other ones that ring. So Right, so I'm going to call that a minor ring. This is interesting. Oh, I forgot to say, we're testing into a 20K load. And so these things might look a little bit different depending on how we loaded these things. Now 20K isn't going to change as much because, as we know from the schematic, the output of this has a 10K just soldered across the output. And so 20K is an easy load for this. And we're going to find that out pretty soon because the next set of measurements that we're going to be doing, we're going to be testing the output impedance of all these various modes, and that will be interesting. All right, let's do output impedance. We're going to start with up. Right. And we're just going to start at 3 volts peak to peak, and we're just going to put this pot in, and we're going to bring it right down to 1.5 volts peak to peak. Then we'll measure the pot. Got a little 20 turn potentiometer here. We're looking for 1.5 peak to peak. Down we go. Oh, and we don't have to be exactly perfect here. We just need to be in the ballpark. All right, so we've achieved it here. Now we just take these out, take this out, and I'm gonna set up a little jig so we haven't got to take it out and clip these on every time, but for now we'll just take that out and clip it on like that and see what we get. 247, we'll just call that 250. So, up, output Z, 250 ohms. Excellent. 250 is a very nice impedance, output impedance for a preamp. So I'm perfectly happy with that. The next thing we're going to test now is down. And we're going to once again shoot for exactly 3 peak to peak, which it looks like we're already at because we're in a similar gain mode here. I want to place the pot back in here. Like that. And we're looking for 1.5 on the nose. And so let me twiddle this. That's too far. 1.5. That's it right there. All right, we'll pull that, put it in over here so we can test it. Let's see what our output impedance is for the down position. A little bit lower, 211. Interesting. You would expect those to be similar, but they're not exactly the same. All right, now let's try. Our next one is going to be up, down. This is our lowest gain position. Let's bring this up so we get that 3 peak to peak is what we're looking for. That's close. That's it. 3, oh, that's a little bit too much maybe. Down. 3 peak to peak. All right, I'll put the pot in and twiddle it until we get 1.5. And that's it. All right, let's take it and measure it. Oh, very low, 115 in our lowest gain mode. So you see what you give up for gain. You gain an output impedance. So 115 ohms in the up-down position. Very nice. All right, and our final gain mode, our highest gain mode, is the down-up position. Down-up. And so we need to bring our input down until we get our 2 or 3 volts is what we want. We've gone past it. Oh, 3 volts. Nice. And then we will put the pot in. And you can see that this is way too much for this. It's very much bogging it down. We're trying to get 1.5 volts. Getting close. And that's it. Let us see. Our highest gain will also have our highest output impedance, but still should be quite low. 478. So 478 is actually closer to what you would want out of a box like this, because industry standard is actually 600. And so all of the gain modes on these are actually a little bit below what you would expect. Now lower is not bad, but lower can cause issues for like a transformer input something or other, because it can cause the transformer to ring if you present it with too low of a primary impedance. It's not usually a problem. For anything that's a resistive input or something like that, these low impedance numbers are actually good because they lower noise, because there's just less resistance to ground for any noise that might want to enter the signal path before it hits the input of the next device, right? Right. All right, so that was fun. Now we're going to look at headroom. I want to see where is the maximum unclipped voltage for each one of these modes. So let us start in up. This will be interesting. I actually don't know what the headroom of this device is because I didn't ever test that much. Let's see what we can do before it decides to quit on us here. Wow. So this is more voltage out than you would ever want. All right, so I've literally hit the maximum input voltage here of 20 volts on my scope, and so I'm just going to go ahead, and we're getting an output voltage here of 23 volts peak to peak. So usually most things like this, like buffers, whatever, they'll give you 2 volts RMS out, you know, and this is doing nearly 8.5, right? And so, or a little bit over 8, and so that's absolutely gobs of headroom for something like this. You will never need this. So I'm just going to write down in that box a large, I guess. Large. All right, let's bring that back down a little bit here, and we'll switch now to the next mode, which is down. Let us see. And once again, it might just be barely clipping there. I think we're just barely clipping there. I think we've reached it. And so our output is 23 peak to peak, 8.2 volts. I guess I'm going to write in for the down. 8.2 RMS. Right? All right, now next one, let's see how we can do in the lowest gain mode, which is going to be up-down. Right? And we probably aren't going to be able to. Yeah, so it has a lot of headroom, but it looks like we get up to 5.2 volts RMS with the input here, but it doesn't look like it's clipping, right? So I can't. We'll just say it's, you know, good headroom. I need a signal gen with more juice to really see how much headroom this thing actually has. And then our last one. This is the one we're probably actually going to be able to see the output clip on this. Is going to be the down-up position. That is our highest gain mode. Let's see what it will do here. And once again, actually, so this test is not telling us that much, except that you will never actually clip you'll never actually clip this, because you'll never have a source plugged into this thing that gives it 24 volts, and you're never going to have anything that asks for 12 volts or whatever, you know, or 35 volts peak to peak out. That's just not something that's going to happen, right? So we'll just say that the headroom for all the gain modes is very, very good. Good. Nice. So for the next round of tests, we're actually going to need to swap out all this stuff here for the computer and the sound card, so we can actually get a better look at the frequency response and the distortion and the noise performance of all these different modes. So I'm going to get that all sorted out. All right, so I've got this all set up to run sweeps on it and everything. And one thing that I noticed straight away is that, you know, unlike a power amp, you know, we're talking about signal level stuff here. And so signal level stuff is very touchy about how you sort of set things up and where your wires are going. And so we're not going to achieve like the best results like this. We would probably want something a little bit more organized than this. But still, one thing I wanted to show you straight off the bat was I noticed that I had some hum. And I was like, wow, that's a lot more hum than I remember when I first assembled this thing. What's going on here? And so what I did was, the first thing I did was I flipped my ground lift switch. So let me flip my ground lift switch here. And look at that. Straight out of the box, 60 hertz. 60 and 180, which is a product of 60 and 120, right? 60, 70, yes. And so, I mean, check that out. I was like, whoa. And so the first thing I did was flip my switch here, and away it goes. And so ground lift switch, that's the one on the output, does something useful for this preamp. The input ground lift didn't have any effect. Here's another interesting thing that I noticed actually after I had built the amp. Including an input capacitor actually will increase sort of the rumble noise of your system. It doesn't change the noise up here, but look, as you get down through the mid-range and the low range, it dramatically reduces your low frequency performance, having just a simple capacitor at the input. So things like that really make a difference when you're measuring at this level. The other thing that I noticed that made a big difference was, well, right on cue, because I was going to talk about it, was having my meter connected. Now the meter itself is not generating any noise, but look at these leads just flying out here. When I connect the meter, which we'll have to do to set, we're going to have to connect it so we can set the actual the voltage that we're measuring. Look what suddenly appears, 60 Hertz. So that's just the leads of the probe. The probe leads just picking up 60 Hertz somewhere in the room or whatever. And so you can see how sensitive the test setup is here. All right, so how are we going to test this? The first thing we're going to do all of our up, down, up, down, up. And I should have mentioned this previously, but that ends up being series, parallel, series, parallel, series. And I'll mark that all down in the measurements that I pop up on the screen, so that we'll be able to keep track of that really well. So the first thing we're going to do is we're going to test all modes at 0.5 volts RMS output. That's a good place to measure because that is like right in the sweet spot of where a device like this will be typically asked to work in. And then we're going to do the same measurements all over again at 2 volts RMS output. 2 volts RMS is kind of like the maximum that a device like this would be asked to deliver. And so that'll show us sort of the maximum distortion, right? And so we're going to look at signal to noise, signal to hum, and frequency response, right? And distortion at all the different modes. So it's gonna be a journey, but I love this kind of thing, and I hope you do too. Anyway, let's start with our first mode here, which is series. That's up on the switches. Let's bring our signal gen in here and see what we get. All right, here's our signal. We're going to bring it up to 0.5 volts RMS. That is really close. That looks good. Okay, so 0.51. Can we get closer? 0.507. Looks like that's as close as we're going to get. Okay, so at 1K, so this is the moment. Now we know we're at 0.5. We don't bump the level. We disconnect the meter because remember those probes were picking up hum that we don't want to record in our result here. And so it looks like at 1K at 0.5 of a volt, we're looking at a total distortion of 0.0046. So that is actually approaching probably the measurement capability of my box. That is to say, there's a really great result. And you can see that our harmonic distortion is sort of the typical second, then third, then fourth type of thing. So a nice distortion there at 1K at 0.5 volts RMS. Really happy with this result. Now with a power amp you wouldn't need to do this, but I know that this interface does develop a little bit of noise on its own, and so to now compare this to the noise only of the amplifier, we're going to take the volume here and we're going to turn it all the way down. You can see even with the volume all the way down, it still generates a signal because it doesn't completely turn off, but this gives us a better idea of where the noise is. And so the noise is down here at negative 30, about negative 30. Our signal was up at 80, right? So it's 80 plus 30, for our hum measurement, right? 80 plus 30. So that's going to be 110 dB signal to hum versus 0.5 volt RMS. I want to write that down. All right, next up, we're going to be looking at 2 volts. So we're going to just stay in this mode, and we're going to go right up to 2 volts now. So let's bring down the sensitivity here. Can we achieve 2 volts in this mode? Probably. We might have trouble achieving 2 volts in the low gain mode actually, because the interface may just not supply the appropriate output for that. That'll be fine. Good. Now let me just bring this back up so that we're at 80. That way it'll be easy to do our measurement here. All right, so we're at 80 with our signal level, now at 2 volts. And our distortion has risen to 0.019. And now let's see what our new signal to noise ratio is. This time I'm just going to go turn off the gen. I'm going to turn down the signal that's not even on. And we know we were at 80, right? And so our hum now, oh, we got 60. You know what that is? My scope, or my meter. We'll undo that. All right, so now you can see that versus 2 volts, we're below -40. We're like, we'll just call it -40, but we're about 2 or 3 dB below -40. So it's going to be 80 plus 40. So that's 120. We'll just call it 122. 122 signal versus hum. All right, and our signal versus noise. Noise is down here at, let's see. Noise is like -53. So that's 40, 30, 133. 133 signal to noise versus 2 volts. All right, excellent result. Let's try our next mode. It's going to be down, down. So that's parallel, parallel with a gain of 0.97. Down, down. Let's connect our scope up again, our probe up again here. So we can see what our voltage is going to be. We're going to begin giving it signal. And bring up signal here. We're going to go for 0.5 again to start with. Now that we are in down, down mode. .5, very nice. Now we'll disconnect our meter. Yep. And let us see what we see here. Our distortion in this mode at 0.5 volts RMS is 0.0062. So that's a little bit higher. That's just a touch higher. Let's see now. Okay, now we're going to check out our noise performance here. We were at 80, right? That's our signal. Let's go ahead and turn off our signal. We're going to look down here and look at our noise. And our noise is down here at, it's below -20. I touched it, so it went up. It's below -20. It's like negative, it's not quite -30. Let's say it's -20, -28 or something like that. -28, I think, is what we're going to call that hum, right? So it's going to be 80 plus 28 for our signal to hum right there. So that's going to be 108. That's looking good. All right, next up, we're going to go right on up to 2 volts. Let's see how we do. That's really close to 2 volts. We'll just call that 2 volts. Let's bring our signal back up to, oh, it's very nearly at 80. Yep, 80. All right, so first things first, our distortion at 2 volts, don't do that, is going to be 0.024. So what we've learned here is that the distortion is slightly higher and the noise is slightly worse with down than it is with up. So that means series mode is a little bit better than parallel mode in this respect. Let's have a look at our noise performance now. So if we're down here at -40 or so, I should turn off the signal. Down here at -40, where we're at 80. So that's 120 dB versus hum. 120. Very nice. And our noise is down here. Let's see, -53. So it's 133 versus noise. Excellent. All right, so the next mode that we're going to test is going to be series parallel. That's up, down. So this is our this is our lowest gain mode. We may actually be able to achieve 2 volts here, but we'll be able to achieve 0.5 volts RMS at least. And that will be enough, probably. There, perfect. 0.5. Now we'll bring this up until we've achieved 80. We're just changing the input sensitivity of the measurement device so we get apples to apples and everything. All right, we're at 80 dB for our fundamental. And let's look. Our distortion, 0.0029. So that's our lowest distortion measurement mode so far. Interesting, very interesting. Okay, so now let's go ahead and look at the noise and the hum. Disconnect this, turn off the gen, turn down the input to get the best noise here. All right, so our hum is going to be at -29, and so that's going to be 119 signal to hum versus 0.5 volts RMS. Very nice. And let's see, the noise floor is down here at -46, and so it's going to be 126. All right, let's move on to the 2 volt test. Connect our probes back up. Turn our gen back on. Bring on up here. Put this down, we'll go up to 2. We'll see if we can achieve 2 volts. We may not be able to hit 2 volts because we're in less than unity gain here. Can we do it? We cannot. So we're not going to get a 2 volt measurement in the low gain mode, sadly. But that's fine. We got a 0.5 volts. We can measure it at that at least. So now we're going to move on to the final mode here, which is down up. That's going to be parallel series. That's our high gain mode. Where we get a gain of 1.45. Let's do it. So we're doing down, up. Nice. All right, so we're already gone past here. Let's go down to 0.5. Subjectively, this is the mode that I like the sound of the best, so it's be interesting to see what it compares like. Of course, after this, we're going to do sweeps, and so we're going to get a better idea of the total frequency response and distortion of the unit at that point. For now, we're just getting basic numbers versus signal at 1K. It's a good way to do it, really. All right, so here we go. 0.5 volts RMS in the high gain mode of parallel series here is going to be 0.028. So that's pretty funny actually, because this is by far the highest distortion mode. As you would expect, you're asking the transformer to provide gain, so it's not surprising that it would be the highest distortion mode, but the fact that I like this mode, the sound of this mode the best, just shows you that the best sound is not always the lowest distortion sound. The worst sound is generally high distortion, but a small amount of distortion from a tube or a transformer can actually add to the sound, interestingly. All right, so now let's check out the noise performance versus this 0.5. We'll disconnect the probes. It was at 80, yes. We're going to turn off the gen. We're going to turn down the box volume, and we're going to look at the noise. So our hum is at -27. And so our hum versus 80 is not as good anymore. This is just 107 dB. And our noise is down here at -41, and so our noise is actually going to be 121 dB. Right? Right. All right, let's look at 2 volts now. Let's bring our input sensitivity up so that we're at 80 again. That'll make things easy for us. That's about it. All right, so our distortion at 2 volts in high gain, which is going to be parallel series mode, is going to be 0.058, which is our highest 2 volt distortion measurement. Still very low though. All right, now let's see what our noise is like versus 2 volts. So we'll turn off our gen, disconnect our probes, turn down the volume, and we were at 80, and so now hum is down at, it's quite low, hum is down at -41, so we're looking at 121 versus hum, and versus noise, noise is down here, like that, 132 dB. All right, so this was pretty comprehensive in a lot of ways, but we were only checking at one frequency. And so next up, we're going to do sweeps, my favorite thing. We're going to sweep at all those different power levels. We're going to sweep all of the modes. We're going to sweep them at 0.5 volt, and we're going to sweep them at 2 volt. And we're going to have a look at the frequency response. We're going to have a look at the distortion across the whole spectrum. I'm super excited for this. I don't think I've ever done this with this circuit before, so I'll be as surprised as you. All right, so the way I'm going to do this is I'm going to sweep them all the modes at 0.5, I guess, first. And then we're going to sweep all the modes at 2 volts. I think that's going to be the easiest way. So we're starting here in up, that's series. And you can see we've got 5 volts out here. And so now we're just going to go ahead and turn off the gen and do a measurement. All right, we'll start at 20 and we'll end at 40K. That sounds about right. Let's try it. Looking good. We're hitting our target 0.5 of a volt there. And that looks outstanding. Outstanding. All right, so this is, it's up, 0.5 volts. 0.5 volt RMS. Very nice. And so you can see the noise is just, we don't even look at the noise. We've already looked at the noise, but you can see it's down there. And you can see here is the second and the third, and then everything else down here. And you can see this agrees with our previous test of, what do we say? Our previous test was versus 0.5 up was 0.0048. And we're down here at 0.004. And so this agrees with our previous test there. Now let's have a look at the frequency response here. All right, so this is 2 dB. Let's go ahead and zoom in. All right, that's 1. This is 1 dB. And so you can see we're still, let's do a half a dB. All right, so this is half a dB. So you can see that we are half a dB, within half a dB from 20 hertz, which is where we started our measurement. Right? We're within half a dB. between where we started and what 40K, where we ended up, right? So frequency response is excellent. And the ringing, I know that we saw a little bit of ringing on this. We can see that it's out. All right, so that went really well. You can see that the frequency response is actually doesn't change hardly at all between the modes and the power levels. So it's very closely grouped here. These are just, these are relative because I'm adjusting the input value to always get to that just right in this area. So just look at sort of compare basically just the curve itself. You can see they're all nearly identical, so no problems there. You can see distortion, that's up, up, and down, down. You can see up, up is lower distortion than down, down, so up, up, that's series, series. So series, series, slightly better than parallel, parallel, it seems, as far as distortion goes. And we've got our low gain mode, which is series parallel here. And you can see that it is the lowest distortion of the bunch here of the 0.5s. And then here's the high gain mode, which is the highest distortion of the 0.5s, which I guess is not that surprising because you sort of can trade gain for distortion here a little bit. But like I said, the high gain mode is kind of my favorite one. And so what does that say? I don't know exactly what that says. And then also, oops, that was the wrong slider. Also, we look down here at the 2 volts. Now remember, we couldn't get 2 volt RMS out of our low gain mode, so we can only look at the series, series, the parallel, parallel, and then the parallel series, right? So here's up, up at 2 volts. Distortion's looking pretty nice here. We're not seeing like a ton of rise at low frequencies, so we're not saturating our transformer or anything. And this agrees with our previous measurement here, where we're looking at 1K, a 0.02. And that's about right, because this is up, up, and we measured a 0.19, so we're very close to our previous measurement there. And here's down, down. Now this is interesting, look at this. So we go 2 volts down, down. So down, down, that's parallel, parallel versus series, series. And we are starting to get a little bit of saturation distortion creeping in here. This is what it looks like when a transformer saturates. You start to see creeping up distortion at the low frequencies. Interesting. You would think those would be very similar modes, but they are slightly different, particularly in the distortion at low frequencies. Yeah, it's neat. And then here, this is our high gain mode. This is our parallel series, right? And as you can see, there's not a lot of saturation distortion, but distortion overall is just higher, but it's primarily second, so it's completely second order here. And so maybe this is why I like it the best. Maybe it's because it has a slightly predominant second order distortion creeping in. So, to sum up, this thing has exceeded my expectations. The noise performance, the signal hum performance, all the various modes, the output impedance is great. Distortion is very low. Frequency response is excellent. Just goes to show why I'm always happy to put this little guy in my system. It doesn't do anything wrong. And it allows some options. It allows me to break a ground loop. It allows me to drive a balanced output, It does a lot of really cool things. Plus it looks really nice. So it's got a lot going for it. If you've stuck with me this long, thank you. Thank you. This is what I love. Let's test some stuff. What should we test next? I don't know. I'll figure it out and then we'll test it. It'll be great. All right.